Welcome to week 3. The lecture for this week is going to be the prerequisite review. A lot of this information is stuff that Ford thinks is pretty important, and some of it comes back to haunt us at the time of the certification test, so I feel like it's important to talk about these ideas. And they're also going after clearance measurements in a slightly different way than they have before, which I think makes a lot more sense. So let's hop on in. Question 1, what's the name of the rings being identified and what is their purpose? So in this case, they're looking at these rings on the outside here, and you can kind of see them here as well. I have a clutch, I have a steel, and then I have this other ring that's a little bit larger diameter than my clutch assembly itself. The point of this ring is to keep the clutches and steels apart from each other so that we don't have drag. In a 4, 5, 6-speed transmission, there's always going to be at least a couple components that are engaged. So the number of components that are disengaged that may have a little bit of drag, there just isn't a huge number of them. So that drag doesn't connect and add up to anything that they considered super substantial. When we get into 8 and 10 speeds, however, there are multiple components that may not be used, and that stacked tolerance of drag adds up to a substantial power loss. And fuel economy loss is the major point of this that really goes against the whole purpose of having these high multi-speed transmissions. So they put these rings in there to make sure that we have as little drag as possible. And when this is all installed inside of a clutch drum assembly, that ring can't walk around anywhere, so you don't have to worry about it wiping out a clutch. But it should be larger in diameter than the clutch material itself. It should not be touching the clutch. It's pretty interesting when it comes to this drag issue, because the Ford Edge has had the same transmission in it for a pretty long time, up until pretty recently. But the 6F50 6-speed front-wheel drive 500 pound-feet of torque capacity transmission started out with the Mercon 5 transmission fluid in it. And around 2010, they updated it to the Mercon LV, which is the fully synthetic, low viscosity fluid. And that low viscosity did a pretty incredible thing for these transmissions, especially in the all-wheel drive options that had pretty poor fuel economy. Switching the transmission over from a thicker fluid to a thinner fluid reduced drag to the amount that these vehicles were getting 4 to 6 miles per gallon more, just with different transmission fluid in it. And that adds up. Think about all the vehicles out there driving. 4 to 6 miles per gallon is a lot of fuel savings. And as these CAFE standards increase and become more and more difficult to meet, all these little tricks add up together to give the manufacturer some tools to try to meet those fuel economy standards across their entire fleet. Number 2, the measurements shown are for which in-play clearance check. This one, it looks all complicated and stuff, but really the answer is given away because we're looking at the pump, which would be in the front of this transmission. This is a transmission to a longitudinal design. And what's being measured here is depth with a depth micrometer, and we just have this gauge bar that should be nice and flat, it's machined, should be the exact same length because it's a measurement tool. But what we have is, this is the surface, because this pump's upside down, it would go in, obviously the other way. But this surface right here is where the selectable sits. So this sits on top of the selectable. And then this surface that they're measuring down to is where the pump actually bottoms out in the case, where it would be bolted down. You can see a bolt hole right there next to that depth micrometer. So when we take this measurement, we're figuring out where the pump starts as far as the machined part of the pump that can't be changed. And then we measure down to the next part, and that gives us the entire height. They actually don't show it in this, but you would end up measuring this bar's thickness as well and subtracting that, right? So you subtract the bar's thickness from this measurement, so you just get this much. And then we subtract that measurement from this one, so that all I'm left with is the distance from here down to that mating surface. So the height of the pump is basically the idea. That is going to go down into the transmission, and where it sets on the case, then this piece is really just kind of dangling down into the tunnel of the transmission. and there is a selective shim that goes in there. And all we want to do is know how thick it needs to be. We have a specification. The internals of the transmission are precision machined, so everything should come out consistently the same. And so we're just making sure that the selectable that's in there is right, so that when I bolt the pump down, I don't squish anything and break some of those Torrington bearings, the little flat washer bearings that are in there. And also, if I have too much play, some of the assemblies could walk back and forth, which would make it so my hydraulic passageways don't line up. And hydraulics are how these transmissions function. So I would lose the ability to hold or drive a component. We get slippage, and the transmission would create too much heat and eventually burn itself up, because heat's the real thing that we're trying to stay away from inside of these transmissions and transaxles. How many different output ratios are possible from one simple planetary gear set? This goes back to the first week of class, and the answer to this one is 7. We've got a few different power flows. Right, we have 2 underdrive power flows in forward that give us 2 different ratios, 2 overdrive ratios in forward that give us 2 different overdrive ratios, and I get direct drive as well. And then my other 2 ratios are in reverse. I hold the carrier, and I either have an input of the sun gear or an input of the ring gear, and that just gives me a basic underdrive or overdrive in reverse. So 7 different ratios from one planetary. Again, like I said before, the transmission just would have to be outrageously huge to be able to drive and hold the same components of the planetary gear set. And so what they do is they use compound gear sets or line simple planetary gear sets up in series to give us the ability to create multiple different forward gear ratios. But this basic idea of these 7 ratios gives the engineers and designers of the transmissions and transaxles a fair amount to work with, and they just figure out what's easiest to accomplish to give them some of the ratios and consistency of upshifts as possible. And of course we want underdrive in reverse, because we're going to be doing that from a stop. We don't want an overdrive reverse. Our bits and pieces. And then there's a pretty nice chart that shows the way that the planetary is actually has the power flow that goes through it. But we've played with this a fair amount. So there's our reduction, and for reduction our carrier is going to be the output. So you can see that the carrier is actually moving slower than that ring gear, and the planetary gears walk around the sun. Direct drive, we just have 2 components locked together, or 2 components driving at the exact same speed. You can see there's no planetary pinion walking around the sun, so it's 1-to-1, basically just a locked shaft. And then for overdrive, our carrier will be the output, and this is just the basic power flow of gear reduction that was shown in the first moving image, but just reverse. So instead of the carrier being the output, now the carrier is the input, and you can see that it's overrunning the ring gear. Then reverse, we hold the carrier, and we get our reverse planetary power flow. Carrier stays stationary, the ring gears act as idlers, and our internal and external gears now rotate in opposite directions. Who knew? What type of planetary gear set uses 1 planetary carrier with 2 sets of pinion gears, 1 long set, 1 short set, 2 sun gears, 1 ring gear? This is basic planetary construction understanding. It was in the PowerPoint for the first week. It's in your book. It's in a 4R70, the only planetary gear set. It's our Ravigno gear set. And for this, we have a common ring gear, but we have long and short planetary pinions and a long and short planetary sun gear set. And this is a compound gear set that gives us more than 7 ratio possibilities. And there's a nice little block diagram showing power flow in first gear there. Purpose of a one-way clutch. One-way clutch engages and holds a planetary gear member in one direction and releases and overruns in the other. So think about a ratchet. It spins one way and holds the other way. One-way clutch. Clutches in one way and overruns in the other. We have a few different types. So this is our roller one-way clutch. This just has balls sitting on spring seats. So depending on which way that outer member is driven, we get an overrunning condition or a locked condition. This would be our rocker style. And this would be if you've ever spun a wheel on a vehicle up on a lift and heard clicking on the inside. This is what you're hearing click. This is a lot like a ratchet on the inside. So you see that inner member being driven, it overruns. And then when they go to drive the outer member, it locks all together. This is how we get engine braking for the most part out of transmissions. Diode style clutch. This one should never be taken apart. If you take it apart, it is possible to get it back together again, but it's not very easy. Everything goes flying. And on these, it looks in this animation like when this locks up, all the diodes are actually grabbing. But in reality, only about a third to 2/3 of the diodes are grabbing at any given point. There's enough of them there that they don't all need to engage to lock it. And the reason that they do this is they offset, instead of them being evenly spaced around the circumference of this one-way clutch, they offset it so like the gaps are a little bit different in between them. And that makes it so that when it goes to lock, it doesn't have to travel in the opposite direction as far, which really accomplishes a smoother shift feel and a lot less impact on the component itself. On the new 10-speed and front-wheel drive 8-speed transmissions, you're going to start seeing these hydraulic selectable one-way clutches. So this uses an electronic and hydraulic system together, basically like a solenoid on the side, to either engage or disengage the one-way clutch. And you have to use the special tester, which is an essential service tool, so your shop should have it. And you can see the tool number there, 307-753. 307 is all of our transmission tools, 7 transmission. You can actually watch it work. You cannot test this without that because it supplies the right amount of current. If you tried to just hook this up to battery power, you could actually fry it. It's just playing all by itself on this one, and you can see how the mechanism locks itself. So this is our electronic lock selectable, and then on our hydraulic selectable, there's a solenoid in the main control that either supplies or limits hydraulic fluid flow to this component. Why are bearings and bushings critical components in any transmission? Well, we'd all have to agree all of the above. They provide smooth rotation, which is important, reduced friction between components, which makes the components last longer and reduces the amount of heat, which heat will destroy our transmission fluid very quickly and then by proxy destroy the transmission. And they also are different thicknesses, especially the bearings, and are selective thrust bearing. I guess they're thrust bearings, but they tend to just be like washers that have enough fluid on them that make them slippery. But they help create our stack height that lines all the components up together and provides sometimes clearance for some of our applied components as well. A bushing number 1, a thrust bearing number 3, and a Torrington bearing is number 2 on the right there. Which one of these 2 bearings is installed correctly? And what they want you to look at is this little piece here. It's not uncommon to have raised edges to bearings on one side or the other, which one helps locate the bearing on the component, or the component that's going to set on top of that bearing. And 2, often it's the way that the bearing's put together. So the way that I always test this is just look at the component that it's going on to, look at the component that it's meant to go on to, and you can even sometimes take the bearing and just set them on either one of those mating surfaces and make sure that it feels like the bearing is sitting on there flat. If it's raised, like this one would be here with it on upside down, you'd be able to push on it and actually rock it back and forth because it's not making good contact. So it's kind of a experience that just takes experience to get used to, but it's something worth noting anyway. Transmission fluid level and condition is critical for proper transmission operation. Describe 2 types of fluid contamination. I can think of a whole bunch of different ones. We could have water or coolant in the transmission fluid, which would wipe out all of our friction components because they're all glued in with water-soluble glue. So everything from our torque converter to our clutches to our electronic components would have to be replaced. We could have metal contamination. We could have the wrong type of fluid in the transmission. We could have clutch material. We could have rust, dirt, and debris in the transmission. But, use your imagination. All kinds of different things could happen. Transmission fluid level is critical for proper transmission operation. That's definitely true, especially with these new synthetic transmission fluids. They expand an incredible amount, so the transmission does need to be up to operating temperature when you check. So if you're doing an oil change on a vehicle and it seems like the transmission fluid's low, but it's been sitting out in the parking lot and the thing's stone cold, that does not mean you should add transmission fluid to the vehicle. This is the main reason why a lot of dipstick tubes have gone away for transmissions, because they're worried that people will check the transmission when it's cold or when the transmission's not running, and then try to adjust transmission fluid level and end up cooking the transmission. Most of the time what happens is people overfill transmissions, and as that fluid gets up into our rotating components, it can get aerated and frothy, which air in a hydraulic circuit, just like in brakes, is going to take away from our pressure. And just like a spongy brake pedal, if our clutches aren't applying firmly, we can burn up clutch material, but also it's going to really hurt our lubrication passageways as well. This animation shows as the temperature of a transmission increases, how much the fluid level increases. At least I think it does. There you go. Temp's going up, and you can see it's not really until the last little bit there that the level of the fluid in that pan went up, and that's substantial. This could be 20 to 30% of the perceived capacity of the transmission between the freeze point and actual transmission operational temperature, the 6R here. What type of fluid pump is shown? This would be our gerotor. You can see we just have 2 gears, an internal and outer gear. So there's no vanes. It's not electric, obviously. It's going to be driven by the torque converter. You can see the flat spots on that. And I don't see a crescent. So those are what are driven by our torque converter. And you can really, when you take a pump apart, you're supposed to put it back together what you found because of wear patterns and all that kind of business. But you can always tell which way is supposed to face the torque converter because it will have a beveled edge to it to make torque converter installation easier. The other side of the gear is a perfect right angle, which makes it really, really hard to seat the torque converter all the way into the transmission or transaxle. So it would be a bummer to get it all together, go to put the torque converter in and realize, oh, it's not going in all the way, or even worse, not realize it's not going in all the way, and end up wiping out a pump when you squish everything together, sucking it together with the bolts, as I'm sure you would all be interested in trying out. And this is what our gear and crescent pump looks like. So on this, I still have an internal gear and an external gear, but I also have a crescent built in, and this just allows a larger volume of fluid to flow through this pump. There would be our vane style pump. It's a 6F50 is what's being shown there. So this is like a little power steering pump. Many of the longitudinal transmissions have gone to this as well because they can make them variable so that there's less drag on the engine when we don't need it, and that increases power and also fuel economy at the same time. Non-serviceable. Do not take a vane fluid pump apart. How are transmission coolers and lines serviced when a transmission is replaced or rebuilt? Whenever we do an overhaul on a transmission, we're going to flush the cooler and the lines. They need to be flushed with a special machine, and you also need to figure out if there's a thermostatic valve somewhere in the lines or in the cooler. That thermostatic valve needs to be up to temperature to open, or in most cases it'll tell you to remove it. In some of the coolers, the thermostatic valve can't really be serviced, and so they tell you to replace the cooler when you do an overhaul. So make sure you refer to workshop manual procedures, because if a transmission had a repeat failure and they realized that you didn't replace the cooler and it said you were supposed to, or you never noted in your story that you did a cooler and line flush, then it is possible for Ford not to honor the warranty on the replacement unit, or on your work for that matter. This is the required transmission cooler flushing machine. You can buy an aftermarket one, but it's actually more expensive than this one. This has two extension cords built into it. One is for a heater inside of the tank that warms the transmission fluid up, and you can see there's a thermometer right there on the side of it. The other is for the pump, agitator pump, and so it doesn't just pump in a straight line, it pulses the pump to try to break free any debris that may have been packed into some of those cooler lines. And it also has a flow meter on it so that you can flow test the cooler and lines once you're done, and that would all be just following the procedures for that vehicle, because each cooler and each set of lines is going to have a slightly different flow to it. But this is supposed to happen every time an overhaul is performed on a transmission. Some people will buy these cans of brake clean looking stuff and flush lines out with it, which is better than nothing, but as far as Ford warranty goes, is not enough. We have a ball valve on the top that allows us to start by back flushing the cooler. The pump has one direction that it likes to flow, and so it is going to pack all the debris into the cooler in that direction. So when we first try to unclog it or clean any debris that may be in it out, we want to make sure we flow backwards first, which is going to remove the majority of the debris, and then flow forward. And then there's an FL1A oil filter that goes on there to filter out the transmission fluid, so we don't end up flushing the next transmission with a bunch of junk transmission fluid. Every time we do flush, at the end you're supposed to blow shop air through the lines, and this machine allows you to do that as well. And that regulated air pressure is supposed to help scavenge any fluid that might still be in the cooler and the lines back into the machine, but eventually we will lose fluid as we do these services, so regular maintenance is required. When performing a valve body overhaul, how we check to make sure a valve's not sticking? Well, free movement test is the go-to. Does it move back and forth by itself? They actually say a gravity test on a valve body that still has some transmission fluid in it should work. So we'll watch our two different types. Inspect the bore, make sure that we don't have any kind of scoring, gouges, anything of that nature. Inspect the valve. These are anodized aluminum valves, so this hard coating is put on the outside, and we want to make sure it's not scratched. You can see right here is a spot where it was held when it was anodized, and that does not have any kind of contact with the surfaces inside the valve body, so we wouldn't worry about that. So there we go, moving nice and freely. Be careful not to scratch it while you do that, or scratch the bore. Then a free movement test. Flop should just come right out, and that's a case-by-case basis. When you go to rebuild one of these valve bodies, just holding a valve in your hand for a little bit of time will warm it up and make it swell up to the point where it can actually feel a little bit sticky as it goes into the bore of the valve body. Take a little bit of brake clean, spray the valve off right before you go to put it in. That brake clean, as it changes states of matter from a liquid to a gas, as it evaporates, it's going to steal some latent heat. Think back to air conditioning class. And that will help cool the valve, shrink the valve, and make it go into the valve body much more easily. Oh, I gave this one away. While inspecting a valve body, these marks are found on several of the valves. The marks do not catch on a fingertip when they are physically inspected. What do you conclude? The valve should be cleaned and reused. So this is just some surface scratching. Like if you can't catch a fingernail on it, if it doesn't seem like it's very deep, and it's not an issue. And it also kind of goes in the direction that the valve is moving. And this is legitimately just where the valve was held as they sprayed this coating on it at the factory before the valve body was assembled. While inspecting a valve body, these marks are found on this nickel-plated valve. The marks do not catch on a fingernail when they are physically inspected. What do you conclude? Visual scuffing may be normal. Further testing is needed. So this valve is going to move back and forth in its bore, and if this is an EPC valve especially, or a variable force valve, well, the valve's not variable force, but the solenoid that controls it could be. This valve could be scrubbing back and forth a fair amount in its bore, and so scoring in the direction that the valve normally travels is not uncommon. And if you can't get your fingernail on it, then we would move to our free movement and gravity tests. Which image shows an acceptable transmission mounting position? They're both right. Who knew? Amazing. The bell housing's more than strong enough, and then the second image, which is what's shown in the workshop manual, is definitely strong enough. We're doing a torque converter leakage test in this. So this isn't a press just to hold this block down. The torque converter is full of transmission fluid, and this is regulated shop air going in. So they have it in the press because they don't want this to just blow out, because there's nothing to hold it in there except for the ram of the press. That doesn't mean that you need to press down super hard on that valve block on top. But you should also go back and check it, because I believe you're supposed to perform this test for about half an hour, and depending on the condition of your press, hydraulic pressure may slowly leak down, and you'd want to make sure that this doesn't start coming up out of the snout of the torque converter, causing a fluid leak in its own right. And they're spraying it with soapy water to see if there are any bubbles that are formed in areas that maybe the fluid level's not quite up to. 3 key areas to look for signs of damage to the torque converter during a visual inspection. Inspect the sealing surface for a groove. So this would be this surface here is the sealing surface. Inspect torque converter studs, impeller hub, or bushing for damage. So the studs are where the converter nuts are going to go through the flex plate. The impeller hub or bushing are the inside of that snout, and inspect torque converter for discoloration due to overheating. Torque converters get hot. They're what create the majority of the heat in the transmission. And if someone was abusing their vehicle or sitting and torque loading it, trying to do brake stands and stuff like that, the torque converter can get really, really hot as the turbine and impeller move past each other, causing a lot of frictional forces and heat. And as the torque converter swells, it needs that flex plate, because as it gets hot it grows in size. The flex plate will actually move back and forth to make sure that the torque converter is able to expand and contract the way that it normally would. But there are instances in which you can overheat a torque converter so much that you can actually wipe out thrust bearings inside the engine. You could do damage to the front pump and maybe even internal components of the transmission from there. And anytime you see a torque converter that has obvious signs of overheating, it should be replaced. Do not trust that. Alright, so that ends the prerequisite review. But there's another part that I want to look at, which is just figuring out our clutch clearance. So I'm just going to stick to the metric numbers on here, but you can see in parentheses that there are standard numbers as well. And what they've done is they've gone ahead and measured the clutch pack clearance. So they're getting a clearance of half a millimeter. And when we do that clutch pack clearance, what we need to do is measure the amount of clearance with a dial indicator, or a feeler gauge would work well, on both sides of the clutch drum assembly. So we take a measurement, spin 180 degrees, take the second measurement, add them together, divide by 2, and that's going to give us the average. So in case we ended up making a little bit of a mistake, one, we would see a huge difference between the two measurements, and we'd want to rethink. And then sometimes because of wave plates, you can see this has a wave plate in it, the wave plate's going to put more pressure in some parts than others, so we might get slightly different readings, and that's going to help average out those differences. We then remove the selective, which in this case it looks like our snap ring is our selective component, so it'll be thicker or thinner depending on what we need. And that's going to give us our entire adjustable range. So if we had a snap ring that was basically 1/1000 of an inch thick, this is how much clearance there would be. Then we need to look up the spec and come up with the middle of our specification. Oh, and this is just showing if the selectable was a pressure plate inside of the clutch drum assembly, because we could have a snap ring, or one of our steels could be a thicker steel that's selective. So then we need to look up our specification, which varies by transmission and then by clutch assembly itself. And we're going to pick the middle of the specification, which in this case is 0.91 millimeters or 0.36 inches. Our spec is never going to go all the way down to 0. It's just not possible because we had no clearance. This clutch would be at least partially engaged, and we can't engage two parts of the same planetary together without creating a ratio that might be different than what we were expecting, something like a 1-to-1 ratio, or we may try to drive two totally different gear ratios that would end up locking up our planetary gears, which would be unfortunate. So we come up with our full adjustable range, subtract the middle of our specification, and that's going to give us our new selectable, which there really shouldn't be a reason why the selectable would have changed unless we replaced the clutch drum assembly. And when I took this class, every single one of the clutches that we measured, the selectable that was in it was thicker than what our measurements came out to be. And our instructor looked into it, and this is the guy who wrote the class, and what he found out is that at the factory, when they were coming up with these specs, they were actually applying pressure to the clutch before they pulled up on it and got the clearance with the dial indicator. And so they were saying at least 10 pounds of pressure, downward pressure, needs to be put on these. And when we started doing that, we were coming closer, even though it was a little bit tight still. And there's a lot of effort being put into the 8 and 10 speed transaxles and transmissions to make sure that these specs are right when it comes time to service them, which hopefully will be a long time from now, but we know transmissions. All right, friends, so that's the end of our PowerPoint, and thanks for sticking around.